Hello dear students, یوادارم زۆر باش بن. Today we're going to talk about electron configurations, chapter 4, section 3. Let's begin. What is electron configuration? The arrangement of electrons in an atom is known as the electron configurations. You remember in chapter 4, section 2, we talked about energy levels, right? As you remember, we have energy levels. This is n equals 1, right? Means first energy level. N equals 2, n equals 3, n equals 4 means fourth energy level. We said in the first energy level we have only s sublevel. S sublevel has only one orbital, right? And in the second energy level we have s and p sublevels. So p sublevel has 3 orbitals. In the third energy level we have SPD and D has 5 orbitals. In the fourth energy level we have SPD and F. So F has 7 orbitals, F sublevel. Bash. We also said that S in the first energy level we called what? 1s. And in the second S sublevel, in the second energy level we call 2s. And we said that P sublevel starts in second energy level, means in first energy level we don't have P sublevel. Pasha. In the third we have SPD, align 3s, 3p, 3d. Why? Means in the third energy level. Pasha. S equals 4, look, it means 4p means P sublevel in the fourth energy level. Basha, we have 4d and we have 4f. F sublevel starts in fourth energy level, means in first, second, third we don't have F sublevel. Basha, esta كالين electron configuration, the atoms of the different elements, they have different number of electrons, isn't it? Basha. So where are the electrons in the atoms of each element? So how they are arranged? Where are they? So this is called electron configuration, the arrangement of electrons in an atom. PLHE, electron configuration. It's written different elements have different electron configurations. Why? Because they have different number of electrons. Okay. Rules for writing electron configurations. Bash. So there are 3 rules or principles we use it to write electron configurations. So in this section we're going to write electron configurations, how their electrons arranged in an atom. So we need rules to what? To fill the orbitals of atoms of each element. So there are 3 rules. The first rule is Aufbau principle. Aufbau principle, Aufbau is a scientist. Basha, electrons fill the lowest energy orbitals first. Basha, if we have hydrogen or helium, let's say, helium has 2 electrons. Why? So this is helium. So it has, its atomic number is 2, means electrons number, protons number, electrons and protons number are 2. Pasha, where are the electrons? This is, imagine this is the, what? The helium atom. Where are the electrons of the helium? So are they in P, S, SPD or SPDF? So we have rule. It says the electrons fill the lowest orbitals first. Which one is the lowest orbital by energy? So we have an order that Aufbau did it. For example, it says by the energy 1s is the lowest energy orbital. So and then 2s باشا دواتر 2p, then 3s, 3p, and so on. باشا. So where are the electrons of helium? They must be in the 1s. 1s, this is 1s, right? It has one orbital. So both electrons, they must be where? Here. Why? Why? Helium has two, and 1s can hold maximum two electrons. So they must be where? Here. Basha? Because 1s has lowest energy orbital. So first we fill 1s, cerium order أبكى. You must know this order. The order of filling orbitals. So by the OVO principle, 1s is the lowest, then 2s, then 2p, then 3s, then 3p. Here, look, we have 4s and 3d. 4s, it's in the fourth energy level, right? And 3d is in third energy level. Look at here. This is 3d, this is 4s. So by the energy, 4s is lower than 3d. So first we fill 4s, then 3d. Basha? That's why we write 4s before 3d. Why? Because 4s, agar serial replicate, by the energy is lower than 4s. Sorry, 4s is lower than 3d. That's why we fill 4s. Okay? So here what you need to know. You need to know the Overbore principle, which says electrons fill the lowest energy orbitals, or we can say electrons, they enter lowest energy orbitals. So which one is the lowest? 1s. So you and the others. So you must know the order. 1s, 2s, 2p, 3s, like that. So this is an easy way to memorize the filling, the order of filling orbitals. Here, if you see كاتك n كاتيك when n equals 1 يعني means the first energy level چی معناها تنها s معناها. So we called what? 1s. باشا. كاتك n كات 2 when n equals 2 there are s and p sublevels. So we called what? 2s and 2p. باشا. n equals 3 we have what? SPD, as we talked about in the previous slide. Basha, agar n katet shwar when n equals 4, there are 4s, 4d, 4p, 4d, and 4f. We have 4 sublevels, and so on. Basha, استعمل أمانها زانم. So, how this diagram helps us. إما من arrow كيان باشا, arrow كيان بمشي. I pass the arrow through the orbitals. For example, 1s. لا 1s أو تسبيع كم بمشي وياه. First, the arrow what passes through the what? 1s. كواتا, the 1s is the lowest energy orbital. يعني first we fill 1s. So then, أقدر سيري أملا يمكن I bring back the arrow. So then it passes through what? 2s. تنها توانت 2s ببروايا كاتت 2s. 2s is the second lowest energy orbital. طبعا دواتر من أروكا هنمو I bring back the arrow and pass through the sublevels. Then it passes through 2s and 3s. كاتت 2s after 2p look 3s. بهمان شوا we're gonna continue. Then it passed through 3s and 4s. 3p and 4s. Then 3d, 4p, 5s. So and so on. So this is an easy way you to memorize the order of filling orbitals. You must know this. Please, if you don't know this, you can't solve. You can't write electron configuration for any element. Asha, please memorize it before you study the other slides. Okay. The second rule, Pauli exclusion principle. Pauli says no two electrons in the same atom can have the same set of 4 quantum numbers. Means there are not two electrons. There are no two electrons in an atom. They have the same 4 quantum numbers. Do you remember quantum numbers? We learned in section 2. Principal quantum number, angular momentum quantum number, magnetic quantum number, and spin quantum number. So there are symbols N, M, ML, and MS, right? Sorry, N, L, ML, and what? MS, right? So please try to study section 2 you to understand this principle. Basha. So here, look, this is helium. We said the electrons of helium, they are in the 1s orbital because 1s is lowest energy, right? So here, look at here, this is an orbital, the orbital of s. According to Pauli exclusion principle, an orbital can hold 2 electrons, Basha, orbitalic 2 electron agreed, Basha, but they have what? Opposite spin state. And it means the way that they spin around the nucleus, they're different. One of them clockwise, the other one anti-clockwise. So the one is clockwise, agar bir tambit, Whitman, positive 1/2 represents an electron that spins clockwise. Kata, this is, we're going to look in this electron configuration of helium. Each arrow represents one of the atoms, 2 electrons. From now on, we don't use the symbol of electron, Basha, to represent an electron. Here we use arrows. So the one that's upward, represents an electron كتشيبه clockwise, spins clockwise. Basha, our criterion, according to Pauli, it must have different spin state. If there is one electron, it's what? And we start from left. It must be upward, it must be clockwise. The next one will be downward. The direction of the arrow indicates the electron spin state. So the one that's downward, so it represents what? Anti-clockwise electron. The one that spins what? Anti-clockwise. So according to Pauli, 2 electrons in the same orbitals, they must have different spin state. But if for hydrogen, agar bo hydrogen chona, there is 1 electron, so it will be in 1s, 1 is lowest energy orbital, agar say you can. Basha, if there is 1 electron, it must be what? Clockwise. Kawata o electroni la hydrogena here, the electron spins clockwise. Basha, agar if, so the next one will be downward for helium. Basha, helium has 2 electrons. Okay. So here, if we represent the definition, no 2 electrons, the same atom can have the same set of 4 quantum numbers. Basha, this electron, this is n principal quantum number because this number represents what? The energy levels, n. So L represents the sublevels. So this electron, it's where? It's in S sublevel. So L equals what? L equals 0. So, and for ML for S also it's 0. What about the spin quantum number? MS it equals positive 1/2. Basium electron anakin. Aibu okaytirian esa for this electron L equals N equals 1 like the first one. Esakeshian S equals 0 like the first one. I mean the one that spins clockwise. And the ML akata 0 like the other electron. But its MS equals what? Equals negative 1/2. Basha, look, they don't have the same 4 quantum numbers. They are different in what? In their spin quantum number. Basha? Okay. Here, this is what important you to know. Two electrons in the same orbital, they must have different spin state. Basha? Here. This is what you must know. Okay. Hand's rule man here. According to Hand's rule, orbitals of equal energy, orbitalakani chi, of equal energy, same sublevel, are each occupied by one electron before any orbital is occupied by a second electron. And all electrons in singly occupied orbitals must have what? Same spin state. Second, there are three orbitals, means these are orbitals of, imagine we have 2p, p in the second energy level. If there are two electrons in p sublevel, Basha, p has three orbitals. Why? I'm three orbitally here. In which orbitals are the electrons? If there are two. Agar siri amabkain, alachi, each one of them give one before any of these three orbitals give two. عشا يعني هر یکێک لەمانە ئەلکترۆنێکی پێیت پێش ئەوەی هیچ یەکێک لەمانە دوی پێ بیت. باشە من دوم هەیە. How I'm going to put it? There are three orbitals. I start from left. لە left دەست پێ یەکەم. And it must be upward. يعني ئەگەر ئەلکترۆنێک هەبێ it must be upward. Must be clockwise. يعني دوباره دو الکترونم هەیە. I'm going to give the second orbital. I'm not going to give the first orbital 2 before any of them give 1. Basha. So it's going to be like that. All the first orbitals, the first electrons, they must be clockwise. If there are 3, I'm going to write like that. All of them, what? I'm going to give each orbital 1 electron and upward. Basha. بهريكي كان electronic impia. If there are 4 electrons, I'm going to start from left again. Left doesn't pick. So I'm going to put the electron from the orbital from left side, but it must be downward. What's downward? Be? According to Pauli, an orbital can hold 2 electrons, but they must have different spin state. The second electron will be downward. If there are 5, so look, it will be downward. Pasha? If there are 6, it will be like that. So look at here. Can we write like that? So there are 2 electrons. I have given each orbital 1 electron. You may say, teacher, it's right, but not, because they must have same spin state. So the first one is clockwise. The second one must be clockwise. Actually, always like that. The first electron must be clockwise. So it will be clockwise too. So that's wrong if you write like that. Say the example like itirka. Here, this electron, why this is wrong? This electron must be where? Must be here. Why? And it must be clockwise. So, because each orbital, electronic PM, electronic chon, clockwise, upward. Can I take each of them? I have given 1 orbital, 1 electron. I'm going to start from left. I'm going to give an electron downward, an arrow downward. It represents anti-clockwise. Basha? Esta agar man the orbital amhebe. D has how many orbitals? 5. Basha? If there are 5 electrons, where D has 5 orbitals, contains, D has 5 electrons, contains 5 electrons. How I'm going to put electrons? هر یکی کیان سرتا electronic PM and clockwise. Nabe anti-clockwise be. Each of them. Okay, 4, 5. Esta هر یکی کیان electronic PM. يم للسرتا ها دست بيكمو لدست شب so بمشيوه بوشي به downward به بي Pauli أبي orbital كان electronic same orbital they must have different spin state كاتا أجر أو ششم هبه أجر حوتم هبه بما أجر هشت if there are 8 if there are 9, if there are 10, will be like that. Okay, so we talked about 3 rules. We said Pauli exclusion principle, Auber principle said first electrons fill the lowest energy orbitals, and now you must know the orders. Then Pauli came. Pauli said the electrons, an orbital can hold maximum 2 electrons, and they must have what? Different spin state. Dwyer Hand's rule. Hand's rule says if there are orbitals of equal energy, Basha, yani orbital كان same sublevel. So each of them you're going to occupy by 1 electron. You give 1. Before any of them you give 2, like that. Basha? Before any of them you give 2. You must give each one of them 1 electron. Before any of them give 2. Basha? So here we're going to apply these rules. To write electron configuration or to represent electron configurations. Guys, there are 3 ways to write electron configuration. The first one is orbital notation. Second one is electron configuration notation. The third one is noble gas notation. We're going to talk about in the third period. Basha. Babasi electron orbital notation كين. الله يجي. أما الرجايك بو electron configuration بنوسي. Balam depends on the 3 rules we learned. Basha? Allah يجي. An orbital notation, an occupied orbital is represented by a line. Line kata. This line represents an orbital that is not occupied, means it's empty. Duatrology, orbital's name written underneath the line. Basha? And name orbital agar babbling first energy, lowest energy orbital manchia 1s. S in the first energy level. Amiyakachia number of n. Basha. I'm a number of orbital. It says an orbital containing 1 electron is represented as an arrow upward. Utman har arrowek represent the electronic. And if there is 1 electron, it must be upwards. And if there are 2 electrons, represent as 2 arrows, 1 upward, the other one downward. So it's going to be like that. Basha? Okay? So, here look, for hydrogen is 1s, 1 arrow, and 1 arrow upward, because hydrogen has only 1 electron in its atom. Helium has 2 electrons, 1s, first upward, the second one downward. So this is how we write orbital notation. So agar being bo carbon beacon Basha. And in the exam I tell you write orbital notation for carbon. Its atomic number equals 6. This is what I'm going to give in the exam. Basha. من لتشيو دسبيك من I by the Ovo principle I know the order. The order first I fill the 1s. Why? S has how many orbital? 1 orbital here. هر orbital أتوانين 2 electron بقريد. كواتا من تاشش أرم. So first this is 1s. So 1s2. I'm going to read like the 1s2. Basha. 1s is filled. 1s must be filled. Then I go to the second lowest energy orbital. Second lowest energy orbital chia by the Ovo principle 2s. 2s, s again has only 1 orbital. So an orbital maximum can hold 2 electrons. This is 1s, 2s is the Ovo principle. And an orbital maximum can hold 2 electrons and they must have different spin state. This is what? Pauli exclusion principle. Here, after 2s, what comes? 2p. P has how many orbital? Has 3 orbitals. Esta. So how many electrons left? 2 electrons. Where are the electrons? And where am I going to put that 2 electrons? There are 3p orbitals. So I start from left. Hands rule. Each of them I'm going to give 1 electron before any of them you give 2. Basha. If I do it for nitrogen, nitrogen has 7. So I'm going to do the same thing, but here this is going to be like that. Each of them I give it to. If I do it for oxygen, oxygen چنی هي 8. So this is what 7 دیم لدست چپو دست پی کمو 8 9 عشا 9 is for fluorine, sorry. Then neon will be like that. Basha? This is how we write electron configurations. For what? For the elements. Okay. Let's continue. The next way to write electron configuration notation, electron configuration is electron configuration notation. It's very easy. It's easier than the orbital notation. How? It says you're going to remove the lines. We don't use line and arrows of the orbital notation. And instead, the number of electrons in sublevel is shown by what? Adding a superscript to the sublevel. Basha, look here. Hydrogen, it has 1s, and this is the orbital notation. I'm going to remove what? The line and the arrow. Basha. How many electrons do I have in 1s? 1. So I'm going to write 1s, this is the name of the orbital, and here it has 1 orbital. I'm going to write as a superscript. Basha? Like we can say like an exponent. Basha? So this number represent energy levels. N. Okay, N equals 1. At a S sublevel in first energy level. And this number, this is what? How many electrons in 1s sublevel we have? S again represents the sublevel. Basha. For helium, I'm going to remove the line and the arrow. For what? For electron configuration notation. I'm going to write the name 1s. 1s, how many orbitals does it have? Does it contain 2? So I'm going to write a superscript. Okay? I think that's easy. Here, sample problem, it says the electron configuration of boron 1s2, 2s2, 2p1. Bash. How many electrons are present in an atom of boron? What is the atomic number of boron? And what write the orbital notation for boron? Bash. Electron configuration notation, it's given. Pema align number of electrons. Emma align number of superscripts. Adding, if you add these superscripts together, equals the number of electrons. This number, we said exponents or superscript, they represent number of electrons. Well, now look, this is number, how many electrons in 1s sublevel, Basha. So 2 plus 2 plus 1 equals what? 5. So 5 is the number of electrons in boron. What about atomic number? Atomic number and electron number are same, so atomic number also equals what? 5. Here it says write orbital notation. SM, it's given. It's very easy. 1s Basha. 1s 10 electron man hai یک orbitality. There are 2 electrons in 1s. We change or electron configuration notation for orbital notation. Do 2s. The 2s we have how many electrons? 2 electrons. 1 2. After 2s 2p. P has how many orbitals? 1 2 3. If there's electrons in 2p, you must write all the orbitals if it does not contain electron. And here it has 1 electron. Basha, we're going to start from the left side, and it has 1 electron. So we start from left and you put 1 arrow upward in the left side. Basha, you must write these 2. Basha. So if there's an electron in the 2p or 3p or any other sublevels. Okay. So this is the answer. Here, guys, it's written 2px, 2py, 2pz. So it means this is the 2p, this electron spins on x-axis. Basha, we have x, y, z. This electron in p sublevel the orbital of p sublevel. This orbital, its electron spins on x-axis. So in the exam you don't need to write, Basha, just write like that, what I did for you. Here also this is the same thing, but here it says the electron configuration of nitrogen, how many electrons are present? So 2 plus 2 plus 3 equals 7. What is the atomic number of nitrogen? Again, 7. Orbital notation, I think we did it before. The electron configuration of fluorine also. What is the atomic number of fluorine? 9. 5 plus 2, 5 plus 2 equals 9. How many orbitals of its p orbitals are filled? Basha, here, how many orbitals are filled into p? None of them. How many of them they are unfilled? أما بنوسين بابو fluorine became fluorine 1s 1s2 more orbital notation. Then 2s 2s2. Look, s is filled. We move to what? We move to 2p. So 1, 2, 3. So there are fluorine, its atomic number is what? Is 9. So 1, I use Hand's rule. Each of them electronic EPM. 2, 3. Basha? So I start from left again. Amachan 4, 5, 6, 7, 8, 9. Basha? So it says, how many of p orbitals are filled? P has 3 orbitals. 2 of them are filled, but this is what? Unfilled. This is filled, this is unfilled. Or when there are 2 electrons, paired of electrons means filled. Unpair means 1 electron, it's unfilled. Basha? Half filled. Okay. Here are the answers, Basha. So 2 of them, they are what? 2 of them, they are completely filled. 1 of the p orbital is not filled. Basha, here what about these 2? If it asks how many orbitals of fluorine atom are filled, okay, 1, 2, 3, 4. Basha? Okay. This is, look, here we're going to write electron configuration for all the elements. Here for the first period, چی معنی؟ hydrogen and helium. So how are we going? I think we did it. This orbital notation and electron configuration notation. This is for helium 1s2. This is orbital notation. Basha. من الامتحان أمد به. Basha. Also for electron configuration notation for helium is 1s2. line أكو الرو كان لابين شان electron هي 1s. I'm going to write it. Basha. Esa, we did it for what? First period. This is the first period. In the first period we have how many elements? 2 elements. Hydrogen and helium. Done. So, what about the electron configuration of the second period? Look, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So I think that they're easy. I don't need to write it for you. توليرة چی مهمة بزانید؟ من I tell you write the electron configuration for lithium. Atomic number أكد PM باشا. أما atomic number of lithium is what? 3. And the first element of the second period is what? Lithium. And it ends with what? With a noble gas. Look, periods, they end with a noble gas. Noble gas means they're group 18. Here is neon. Basha? Agar lithium binusin, 1s has only what? 2 electron. The 2s has 1 electron. Basha? Wachi? Lithium 1s2, 2s1. Look, 2p later nusiwa, الامتحان you don't need to write in the exam. Okay? Electron configuration notation. Row line ana labin, we write 1s2, 2s1. Basha? Beryllium also 1s. ل s or b 1s چی معناها 2 electron معناها 2s 2 electron معناها بوشي atomic number beryllium 4. Boron, look, 1s what? 1s2, 2s1. For boron, as we did before, has only one electron in what? In 2p sublevel. This is also like that. For neon, Pasha, is 1s2, 2s2, 2p what? 2p6. All the p orbitals are filled in neon. Okay? Here the order, you must know this order. If you don't know this order, so in the exam you can use that way. Also, it helps you to know the order, or you don't use that way. If you don't use this way, Basha. Okay. Look, highest occupied energy level, outer shell electron, valence electrons. Okay. What is highest occupied energy level? Is what it says, its outermost shell containing electrons that have the highest principal quantum number. Highest principal quantum number. Issa, look at here. I'm a lithium, Basha. Lithium is 1s what? 1s. 2s, 1. Isn't it? Because lithium is this is symbol and atomic number is 3. If you put electrons in the shells, it will be like that. How many electrons do I have in the last shell? We have only one electron. What do we call the last shell in the atom? We call highest energy level shell. ياخد 20 people in chi? Highest occupied energy level. Highest occupied energy is the outermost shell containing electrons have the highest principal quantum number. n equals 1, n equals what? N equals 2. It has highest principal quantum number. Here we have 1 and 2. The highest principal quantum number is n equals 2. So the n equals 2 LNG, second energy level here, highest principal, highest occupied energy level, or 20 highest energy level, last shell, outermost shell, or valence shell. Basha? A cheap electron كألين. What do we call the electrons in the highest occupied energy level? Peeling outer shell electron. ياخد 20 people in valence electrons. Look, outer shell electrons, valence electrons are electrons in the last shell. كاتب electron على outer shell electron or valence electron. Basha? So what about the electrons? They are not in the inner. They are not, in the outer shell. We call them what? Inner shell electrons. Inner shell. Here, the second shell is the last shell. So the first shell is the inner shell. So electron inner shell electron. Electron معناها 2 inner shell electrons. So I think that way is easy, but in the exam, I'm going to give you the electron configuration. Like here, lithium, atomic number is 1s2, 2s1. So which sublevel is in the highest principal quantum number? In the last shell. This is 1s. Look, 1s2. How do you know it's in which shell? Here n equals 1. When n equals 1 s means n equals 1. كواتا ام s لكوية la first energy level. Pasha 1s 2. So number, this number tells us n equals 1. كواتا 1s in the 1s2 is what? In the first energy level. A2s1, 2s mean s in the second energy level. Got it? This is like that. 2s 1. So first a bit to بزاني which sublevel is in the highest occupied energy level. How many valence electrons does the lithium have? I give you the electron configuration like that, you know. So 2s1 is in the second energy level. So It's in the last shell. It's in the valence shell. So it has how many electrons? How many electrons does it contain? One electron. كواتا there are one electrons. أقدر سيري لكي is only one electron in the outermost shell. So 2s sublevel is the highest occupied energy level, is the valence shell. There is what? Only one electron at the highest occupied energy level. There's 2s sublevel, which is in the last shell, contain only one electron. Basha? Fluorine. سيري ربك. 1s2, 2s2, 2p5. As Anam, this number shows that 1s2 is in first energy level, and 2s2, 2p, they are in the second. So there are two shells. The second one is the last shell. Which sublevel are in the highest occupied energy level are in the last shell? 2s2p, because both of them, they are in the second is the last shell. How many electrons they contain? 2 plus 5, 7. Kawata, there are 7 valence electrons. So 2s2, 2p sublevels are in the highest occupied energy level, and there are 7 electrons in the highest occupied energy level. Basha? Inner shell electrons, the shells below the highest energy level, as we said. Here, the lithium with my 1s2 is in the lowest energy level, is in the inner shell. So it contains how many electrons? 2 electrons. Kawata, there are what? Look, lithium, agar serib kain, 1s2 is the inner shell, is in the inner shell, and there are 2 inner shell electrons. Bochi labaroi 1s2 contains only 2 electrons. Superscript represent the number of electrons. Here, for fluorine, also 1s2 is the what? Lowest is in the inner shell. It contains how many electrons? 2. So there are 2 inner shell electrons. Basha? So you can do it for other examples too. Later, inshallah, we will do some more examples. Okay, octet of electrons. ام فيديو توزي دري شويت ايوا اتوانن كام بارتي بدلتانا كام بارتي تينا جيشتون. You can watch it. Okay, this video is going to be a little bit long, so which part do you want? Listen to that. Masha? Okay, octet of electrons. All 3 2p orbitals are filled in neon. Seri neon can 1s2, 2s2, 2p6. Why? Yani all the p orbitals, agar seri orbitally p cane, bo this 2p is like that. 1s, 2p mania. P has how many orbitals? 1, 2, 3. So 1, 2, 3, 4, 5, 6. Anya, it says 2p6, means p contains 6 electrons. If we change to orbital notation, it will be like that. So all the p orbital, all the 3p orbitals are filled in neon. So, Alechi, atoms such as those of neon, which have the s and p sublevels of their highest occupied level filled with 8 electrons. Look, neon, its last s and p are filled. Why? So when s and p are filled, means p contains 6 electrons, maximum can hold 6. Also, s maximum can hold 2. So together 6 plus 2, 8. Kata, when their last s and p are filled, when s and p are filled means 8 electrons. Why? Kata, those, it says those atoms, those elements, their last s and p are filled with 8 electrons. They are said to have what? Octet of electrons. Kawata. Those atoms, their last shell is filled with 8 electron. We say it has octet of electron. Guys, octet يعني چی? Octet means 8. Masha means 8. Okay, so cardinal octet of electrons here refers to the electron configuration of an atom where the outermost energy level, known as the valence shell, contains 8 electrons. Basha contains 8 electrons. So, which elements they have 8 electrons in the outermost shell, or which elements their last S and P are filled with 8 electrons? What? Noble gases except helium. Noble gases except helium have octet of electrons in the last S and last P. Yeah, the turbulent their last S and P are filled. Jiggle helium except helium. Bucci, helium in the last shell we contains only 2 electrons, right? Contains only 2 electrons. So cannot have 8 electrons, but others serif can. Neon 1s2 2s2 2p6 چند electron من here? We learned about highest occupied energy valence shell 2s 2p. They are in the second energy level. Later second energy level here is the second shell, right? How many electrons does it contain? 2 plus 6 8, because S and P are in the last shell. So we count the number of electrons, add the number of electrons in S and P. Here argon also same, its last S and P are filled. The last shell actually here 3s 3p is not in the third energy level. Third energy level for argon is what? Is the last shell, valence shell. So 3s and 3p, they are in the what? They are in the third shell. So together 6 plus 2 8. سيري أماب كان krypton 1s2 2s2 2p6 3s2 3p6 4s2 4p6 a 3d emailing by over principle. We first fill for S and 3d. The last shell, there are 4 energy 4 shells, because we have 4s in the fourth energy level. We don't have 5s, so 4s in the last shell is the last shell. كاتل the last shell هم چیم هيا 4s هم هيا لقل 4p. Basha, how many valence electrons does it have? 8. Krypton has 8 electrons in the last shell. It has 8 valence electrons. But 3D لچنه? The third energy level it's not, it's in the inner shell. Basha, اسا اگر من لیر بلمت how many valence electrons do I have? 8. What about inner shell electron? I have 8. Its atomic number of krypton چنه؟ اگر سری رو بکن 36. 36 minus 8, 20, what? 28. There are 28 inner, what? Inner electrons. Okay? So this is another example. Xenon and radon also, they contain what? Their last S as are filled, they have 8 electrons in the last, except what? Except helium. Okay. Elements of third period. Guys, elements of the third period, if you write electron configuration, سرتا مهمة بزانيت, what do we have? The elements of the third period. Look, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Look, elements of first, second, third, they are really common elements. It's better you to know their name, their symbols. Please know them. They are very important. So, third period starts with sodium and ends with argon. So if we start electron configuration for sodium, Na 11, we say 1s, we start from 1s2, 1s2, 2s, 2, 2p, what? 2p6, then 3s, what? 1. Say it again, do I, after 2s, 2p, after 2p, 3s. Ama creation 2 plus 2 plus 6 plus 1, 11. This is the electron configuration of what? Of sodium. Okay? Let's do it for sulfur. Bohemian Nike. Sulfur 16. Others, they're like that. 1s what? 1s 2, 2s 2 amateur تا 16 روین. We go until 16 2s to 2p 6 3s I'm sorry 3s 2s fills by 2 electrons, then 3p 6 no 10 12 plus it must be 4 3p 4 Basha, we do like that. Okay, but here we have another method, look, which is what? Noble gas notation. Amachia, what's noble gas notation? Noble gas notation is the third method to write electron configuration. اگر بین third period, look, electron configuration is going to be long. We need to make it shorter. So we use noble gas. Look, first 10 electrons in an atom of each of the third period elements have the same electron configuration as neon. اگر سيري بكين ليرها, all the first the 10 electrons of the third period, let me erase this one. Look, noble gas is important. You to know it. Look, say 10 electrons. This is 1s2, 2s2, 2p6. Here, look, it says first 10 electrons in an atom of each of the third period. First 10 electrons of each atoms of the third period, they have the same electron configuration of what? Neon. Why? Neon is what? 1s2, 2s2, 2p6. This is not the electron configuration of neon. So instead of writing this, we can use a way. Instead of 1s2, 2s2, 2p, we can use the symbol of neon, Basha. Then we can put it what? In a enclosed square bracket, la bracket ekadane. Do I amachi mawa? If we write electron noble gas notation for what? For sodium. Here's 3s what? In the 3s we have how many electrons? 3s. We have only one electron. So that's it. Easy. Look, neon 3s1. Basha. Here the symbol this is a neon in a bracket represents what? Represent 1s2, 2s2, 2p6. Because in the elements of third period, the first 10 electrons, their first 10 electrons is the same electron configuration of neon. So why should I make it very wide? So I'm going to make it shorter. I use noble gas notation. Ta'era, this is the electron configuration of neon. من symbol neonism in a square bracket. What's left? In 3s we have one electron where I'm going to write. Let's talk about it. It says this similarity allows us to use the shorthand notation for the electron configuration of the third period elements, as I said, which is called noble gas notation. Cut noble gas notation here is a shortcut for the writing electron configuration. The shortcut for writing electron configuration uses noble gas. This is important. Noble gas to show the inner electrons and only writes the outer electrons. Basha. Neon is the member of the group 18. Group 18, there are noble gases: helium, neon, argon, krypton, xenon, and radon. Basha. So, for examples, sodium's electron configuration notation. Asama electron configuration here, we can use make it shorter. The symbol for neon enclosed in square bracket, here, is used to represent complete neon configuration. Legit neon configuration, I put a neon symbol in a bracket. So this allows us to write sodium's electron configuration as Ne3s1, because until here is the electron configuration of neon. I use what? A symbol in a square. What's left? Write it. Okay? So this is like that. for others too. Here, if you do it for, let's say, sulfur, 1s2, 2s2, look, 2p6, 3s2. Here is the electron configuration. I am going to use neon, and what's left? 3s2, 3p4. I'm gonna write it. Okay? So, elements of the fourth period. Guys, in the elements of fourth period, also, look, we're going to start using electron configuration, noble gas notation in the third period, okay? And other periods too. So for the fourth period, you don't need to know the electron configuration of all the elements. So some of them that are important, and try to know them, like potassium, calcium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, and also here bromine and krypton. Basha? Okay, try to know them. Here also it's the same way, but I'm going to do for one of them, iron, 26. Okay. Look, I start from 1s, then 2s, 2p, 3s, look, 1s, 2, 2s, 2, 2p, what, 6, Amachan, until now, 10, 2p6, 3s, 2, 3p, 6, أما هجدة. After 3p, cheat. This is very important. Sometimes they write 3d. You must write what? 4s. 4s, what? 4s2. Then 3d. After 4s, cheat, d. D maximum can hold 10 electrons. But here, to be 26, we need how many electrons? This is 18, 20, we need 6 electrons. This is the electron configuration of the iron. Fe here, Basha? Okay. So if I write noble gas notation, here is very important. Which noble gas do I use? Here, please know what noble gases. Look, until radon. You must know their symbol and their what? Their atomic number. So which noble gas do I use to show the inner electrons? Here, iron, its atomic number is 26. I'm going to choose, it's very important, a noble gas that its atomic number, and the number of a noble gas must be less than the atomic number of the element I have now. Machim heyasa, iron 26. Tell me a noble gas that its atomic number is less than 26. Chiman here? Here we have what? Argon. Anion ishum helium ishum. Which one I use? I use argon. Bochi, it's less and close to what? The electron configuration of what? Of iron, which is 26. So I'm going to choose what? I'm going to choose argon. So its atomic number is less than 26 and it's close. عشرة أبين نزيكيش بيت كم تربيت atomic number أو noble gas كالي بجرم أبين atomic number أو elementi هما كم تربيت نزيكيش بيت كمان نزيك ترى argon باشا argon I'm going to choose put symbol of argon in a bracket بمشوية. Atomic number iron is very important you to know. It's 18. Until where is 18? 1s2, 2s2, amada 12, 18. So what's left? Chima. After this is represent what? Here. What's left? 4s2, 3d, 6. I'm going to write it after the bracket. 4s2, 3d, 6. Basha? So, here guys, for all the elements of the fourth period, we use argon. We use the noble gas of the third period. Noble gas of the third period, chia, argon. Basha? For bromine also, you're going to do. Again, for bromine, if I write electron configuration for bromine, so I'm going to write until here. This is, sorry, I should erase this. So here, let's change it to what? If I write for krypton, Masha, Kr, can I write noble gas notation for a noble gas? Yes, its atomic number is 36. So for S2 3D10, Amabubachan became 30. After 3S, what comes? 4P. 4P what? 4P6. This is the krypton. So for krypton is a noble gas. I'm not going to choose a krypton itself. No, I'm going to choose argon. Basha? So because I'm going to choose a noble gas that its atomic number is less than krypton, which is what? Argon. So I'm going to choose argon again, but until, so what am I going to write? 4s2, so then 3d10, 3d10, 4p6. Basha, this is noble gas notation for what? For krypton. So in the exam also you can do for all the other elements that I told you they are important. And dear students, try to know the electron configuration of those elements that I told you know their symbol and their name. So these are common elements and you just need to know these, okay? So these are for all. But here, if you look, if I want to erase all, okay. Here, if you look, the in the book is written 3D then 4S, right? You said, teacher, you must fill 4S and 3D. The order in the book is written like that. For 3D, look, 3P, 3D, 4S, 4P, 3D, 4F. But the order is same. The order of filling, we fill first 4S and 3D. There's no problem. Bash. Another thing here, chromium and copper. Pay attention. Why they contain one electron in one 4s? We know that first we fill 4s, then what? Then 3D. But here 4s has not filled, and we have put electrons in 3D. Here also for copper. What are these? They are exceptions. What are? In the fourth period, there are some exceptions. There are two exceptions, chromium and copper. So electron configuration exceptions, chin, are when some elements do not follow the usual rules for filling up their electron shells, usually because it makes them more stable. In the fourth period are chromium and copper. Why they are exceptions? Why they don't follow the rules of Obo principle, Pauli, like that? Because it makes them more stable. The atom of the elements, they are going to be more stable. This is important you to know, Pasha. For chromium, I'm going to do it for chromium, 24, Basha. So I start from 1s. 1s what? 1s2. Then 2s, 2. Then 2p, 6. After 2p, 3s, 2. After 3s, 3p, 6. Look, 3s, then 3p. What comes next? 4s. 4s. Again, if I feel the orbitals of chromium, I must feel it like that by the rules. For s parakam, I feel 4s by 2 electrons. Then 3d. Basha, 3d, 4. I'm at 24. Why? But chromium is an exception. How? An electron has transferred from 4s to 3d. as an electronic, one electron has transferred from 4s to 3d to make 3d what? 5, to be half filled, because d has 5 orbitals. 4 of them, they contain electron, 1 of them is empty, so that electron is going to be transferred there. So it's going to be 4s 1 3d 5 Basha. So to be d sublevels d orbitals half filled يعني يك الكترونيان تاعي. This is what if I write noble gas notation until here is the argon, less than 24 argon. I have argon, so argon AR Basha. What's left? And in the exam you must write like that: 4s 1 3d 5. So if you write like that, 4s2 3d 4 is going to be wrong. Basha, you must write like that. Okay, here. Another one, look. Let me erase this. This is for what? For chromium. Okay. Look, one electron from S has moved to 3D to be half filled. ويحرك كان electronic انتيابه, it makes the chromium atoms more stable. Basha. What about copper? Copper, same thing. In 1s, one electron has moved to 3D to these orbitals be fulfilled, and it makes the copper atoms more stable. Basha, look, بحماشة S لإسوا electronic has transferred to 3D. Okay, so there are two exceptions, you must know them. Elements of fifth period, guys. Elements of fifth period, here it starts from rubidium, strontium, then they are not common. Silver, try to know it. Tin, not try to know, you must know, because there are common elements. Okay, so just know these 6 elements, electron configurations, noble gas notations. Basha. So if we do it for what I want to do it for iodine, Basha. So iodine 53. Okay, let's do it. We start from 1s, 1s 2, 2s 2, 2p 6, 3s 2, 3p 6, 4s 2, 3d what? 10. Asha. After 3d 10, what comes? 4p 6. After 4p 5s. After 4s, what comes? Sorry, I need to erase it. After 4p, I need to write 5s, 5s2, 3d, sorry, 4d 10. Then after 4d, 5p. This is until here. I think this is what? 48 to be 53 needs 5. This is for what? For iodine. Basha. For the fifth period elements, if I write noble gas notation, which noble gas do I use? I use the noble gas of the fourth period, which is krypton. Basha, less than 53. Which noble gas? Its atomic number is less than 53. Krypton. Why? So krypton, I write the symbol of krypton. Okay, so krypton's atomic number is 36. Until where is 36? until 4p6. So after that, I'm going to write these here. Okay, 4s2, 4d10, and 5p5. Okay, but here we have exceptions in fifth period. There are 7 exceptions. You don't need to know all of them. Here, just know silver. Silver the same like the electron is similar like the electron configuration of copper. 1 electron from s has moved to what? From 5s has moved to what? 4d. Pasha? Okay, that's it. Guys, elements of 6th and 7th period, actually in the book they are not mentioned, their electron configurations, because there are many exceptions. So you don't need to know. I'm not going to ask about them. So try to know first, second, third, and fourth and fifth period. Okay. Okay. Here, guys. Here, why in the SPD block in the periodic table. Inshallah, in the fifth period, we're going to learn here why we called 2s means lithium and beryllium. Their atomic number, their last electron is in 2s. We called these here group 1 and group 2, and helium we called s block because their last electron is what? These elements, their last electron is in s sublevel. Here we call d block, and here is 3d. These electrons, their last electron is 3d. These also. Here 2p, 3p, 4p, 5p, 6p also. These like that, we call them p block, the red squares, because their last, these elements, their last electron is what? In the p sublevel. Here their last electron is in 4, lanthanide and actinides. Pasha, sample problem. I think if you look at the sample problems, you're gonna understand. Here just I want to know, explain this. It says how many electron containing orbitals are in an atom of iron. You're going to write orbital notation, you to understand better. For iron you can't do it. It says how many orbitals they contain electron. The answer is 15. 15 orbitals they contain electron. If there is 1 electron, it still contain electrons. And also it says how many unpaired electrons, how many they are completely filled. We know that if an orbital contains 2 electrons, it's completely filled. If there is only 1 electron, we said how many unpaired electrons. Unpaired electrons means how many orbitals they contain only 1 electron. Basha? Okay, try to do it. Also here, which one you need to know? Here, guys, look. It says write the both complete electron configuration notation, noble gas notation for rubidium atom. Pasha to borubidium, okay. The electron configuration for rubidium here it is written. Alechi identify the elements in the second, third, fourth period have the same number of highest energy level electrons as rubidium. Guys, in the chapter 5 we're going to learn here how many valence electrons does the rubidium have? 1, because in fifth there are 5 energy levels. I'm numberana by these numbers, you know. So the largest number of n is what? Is 5. N equals 5. In n equals 5 we have only 5s. It contains only 1 electron. So there's only 1 electrons. So if you write the electron configuration for first, second, and third, you know that the elements here, let me show you here. Rubidium is here. It says in the second, third, fourth period, which element, so they have the same electron, they have the same valence electrons. And rubidium has only 1 valence electron. So how do I know? You need to write the electron configuration. But here this another way we can use. Rubidium is not in the group 1. So if you write for hydrogen, 1s1. Hydrogen does not have only 1 electron in the last shell. Yes. Lithium is going to be 1s2 2s1. Does not have only one electron in the last shell. Second shell is the last shell, yes. Sodium is going to be 3s1. So potassium is going to be 4s1. Means it has only one electrons in the s, and it has only one electrons in the what? In the last shell. So we're going to learn that electrons in the same group, they have the same valence electrons. Basha? So in the third period, lithium, sodium, potassium, they have the same, they are, and rubidium, they are in the same group, so they all have the same what? Number of valence electrons. Kawata, the second, third, fourth period, lithium, sodium, and potassium, they have the same number of valence electrons like rubidium, because they're in the same group, same valence electrons. Basha? Here you can, here I think just you need to know, here gold, for me, I will not ask about gold. Gold is an exception, and I told you you are not responsible for gold here. Basha? Inshallah later we can learn. Here this is a section review. I think there is not a question which is difficult for you. You can check it. They're easy. Basha? Thank you for watching. Hiwadarim Basud Bubet. We didn't have much time. So thank you very much. Inshallah it was useful. Bye.